All right, so I'm just going to solve questions A to F one by one, and we'll just talk through them. Okay, so we know that there's always more than one way to solve a problem. And this one you could say that we could just go ahead and there's only one fraction here. I can clear that fraction out. Or I could save it and go ahead and add 6 to both sides, right? And then so I would have x over 4 is equal to, when I add 6 here, I end up with 1. Then I want to undo the division by multiplying both sides by 4. So remember, we always do the same to both sides, so I multiply both, otherwise it won't be equal. When I do that, I undo this division, so x is equal to 4. I could have multiplied first everything by 4, but I'd have some bigger numbers, but I wouldn't have that fraction there, okay? When you see multiple fractions, I would always suggest to clear the fractions, otherwise we're going to be adding and subtracting fractions, which is, it's not that friendly. All right. Couple things I can do here. I could subtract 4 first, or I can just go ahead and do distributive property. Most of the time people do this. I'm not saying it's the best. It's not. 4 plus, and then we have 3t plus 6 equals 10. We can combine the like terms here. We'll have 3t plus 10 is equal to 10. Kind of got a funny situation here. So if I go ahead and subtract t from both sides, right? Sorry, 10 from both sides, I'll have 3t is equal to 0. And there's only one solution that works for that, right? So we don't even really need to divide by 3. We can already see that t is equal to 0, but we can just go ahead and say t is equal to 0. All right, if I substitute and test that, this would be 2, so 3 times 0 plus 2, right? That would be 6. 6 plus 4 is 10, so that works. Good. All righty, let's take a look at the next one here, distributive property. I can do the distributive property, or I can choose to divide both sides by -12 first, just to undo that multiplication, right? In that case, I would have y plus 5 is equal to, and this is just going to be -12. Or an alternative method would be I go ahead and do distributive property. So I'd have 144 equals -12y, because I'm doing distributive property, minus 60, okay? And let's see, I didn't finish that one, did I? Oops, I didn't even finish that. I was like, oh yeah, I'm done, but I didn't even finish it. Shoot. Okay, so I'm not done yet. So I need to subtract 5 from both sides, so I have -17 is equal to y. Okay, now let's try a different method, where I did distributive property first. So 144 is equal to -12y minus 60, okay? So if I add 60 here, I will have 204 is equal to -12y. This might be a calculator one. So if I take 204, right? 204, and I divide that by -12, we're going to get 17, -17, yeah. So, I mean, obviously we've got the same answer. But I used two different methods. Both of them are pretty much, I'd say, equally valid, yeah. All right, D. We want to isolate u, and what we've got here is division that we really need to undo first. So I'm going to multiply both sides by 6. Multiplying by 6 is going to undo the division. So I have -6 equals 5 plus u. And now I'm going to subtract 5 from both sides. So I have -11 is equal to u. That's it. There we go. All right, got a couple more here. choosing my color. Let's see. Let's go with brown. All right. Distributive property. And then we can combine any like terms. So -2 times 4 and then -2 times -1n. So that'd be -8 plus 2n equals, and they've got the same thing going on here, 6n plus 12 plus 3n. I've got to combine the n's here. So we've got 9n plus 12. Here's the same thing, right? Nothing combined. You know what? I think I'd like to isolate n on the right-hand side. And why would I want to do that? So that I have a positive coefficient when I do that. So if I subtract 2n from both sides, then I have 7n here. And now I just need to subtract 12, right? So it'll be -20 is equal to 7n, right? So n is equal to -20 over 7. Yeah, and that should do that one. That's good. Sometimes whenever I get a fraction that's kind of funny like that, I think, is that correct? By the way, when you're doing these questions, you should always be checking your answer. Always checking your answer. And I should have been better at boxing these in. So I should be boxing them in. Each of them, okay? It just makes it clear where my answer is. Okay, well, let's pick another color, last one. Let it go over here, and oh, I'm running out of colors here. Let's go with maroon. All right, here's the case where we got some fractions, and really, when we look at the denominator of a fraction, that is indicating division, and we need to multiply to undo the division. The problem is I have multiple fractions here and multiple denominators. So I need to find a denominator or a multiple of a denominator that will clear all the fractions. So if I take 6, if I multiply everything by 6, that's not going to work. So I look at the next multiple, 12. 12 is a multiple of 4 and 6, so that's going to work. So if I multiply all the pieces on each side by 12, I will undo the fractions. So 12 divided by 4 is 3. So 3 times r is 3r minus 12 divided by 6 is 2. So 2r equals, and we have 12 divided by 4 is 3. 3 times 1 is 3. So this one's pretty simple because it just simplifies to r equals 3. Well, that one was pretty easy. That's it for those ones.